All right, so now we're talking about covalent compounds, okay? And covalent compounds, of course, we use Lewis structures to understand what's happening with those covalent compounds. And so again, this is where we have some sharing of the electrons, okay? So with our Lewis diagram, we have a few different rules, right? And what I'm going to do to kind of show those rules is use a couple of common examples all the way throughout this, okay? So our first example is going to be OCl minus. And what we want to do is we want to count the valence electrons that are available first. So for OCl minus, right, I look at oxygen and I see that it's in column 16, right? So there are 6 valence electrons available from oxygen. There are also from chlorine, right, it's column 17. There's going to be 7 valence electrons available from chlorine. And then we have a negative charge, so there's going to be 1 more valence electron available. So I should have 14 electrons available to build my Lewis structure, okay? So another example, right? We've got, we're going to do methanol, so CH3OH. If we start to count here, right, carbon is column 14, so 4 valence electrons, plus hydrogen is column 1, so there's 1 electron available or valence electron available from hydrogen, but we've got 3 of them, so we're going to do 3 times 1 here, plus oxygen is 6, plus 1 more for this other hydrogen, and that equals 14 electrons, okay? And so then our last example here is going to be SO3 2 minus. Sulfur and oxygen both are in column 16, so we're going to do 6 plus 3 times 6 would be 24, but it's got a 2 minus, so we're going to have 2 more electrons there, so that would be 26 electrons. Okay, so there's our first thing that we need to do whenever we're building Lewis structures, right? If we need to figure out the Lewis diagram, we first need to count the valence electrons, okay? Then we're just going to draw a skeleton structure. And the way that we kind of start this, right, we're going to start from just carbon always is going to form 4 bonds. We want to start from a central atom that's going to be the first one written in the formula. And then the terminal atoms in general are most often hydrogen, oxygen, or a halogen, okay? Oxygen will go in the middle, but only if it has to, all right? So if we go back to OCl minus, right, my skeleton is really just combining OCl, right? My CH3OH, here I'm going to put carbon in the middle, and it wants to form 4 bonds, so I'm going to give it 4 bonds first. And because these 3 hydrogens are written like that, I'm going to put my 3 hydrogens on the end here, and then I'm going to put an oxygen, okay? And then I'm going to put my hydrogen again. Basically, the way that this molecule was written, it kind of is giving us a hint as to what the Lewis structure is, okay? The last one, SO3, we're going to put sulfur on here. It's only going to combine with our 3 oxygens, and that's going to be our skeleton structure, okay? So then, right, we want to subtract 2 electrons from our count for each single bond. So this oxygen, or OCl, we've only got 1 single bond there. So we had 14 electrons. Now we have 12 electrons left, okay? Here we have 1, 2, 3, 4, 5 single bonds. So we started with 14. 5 times 2 electrons is 10 electrons. So 14 minus 10, we're going to have 4 electrons that are left for our methanol. And then sulfur, or our SO3 2 minus, right, we had 26 electrons to start. We subtract 2, 4, 6, so we're going to have 20 electrons left there. And then we want to distribute those electrons, okay? to give each atom a noble gas structure. Okay? And where we want to distribute them first is going to be to the most electronegative element. Okay? So the most electronegative element, again, is pulling on all of the electrons the most. So we're going to give them their electrons first. So over here, chlorine, right? 1, 2, 3, 4, 5, 6. Now it is up to a noble gas structure because it's sharing 2 here, plus has a 6 of its own. So that chlorine has 8 electrons. It fills its octet. That one's happy. We have 6 electrons left now. So 1, 2, 3, 4, 5, 6. That's all of our electrons done there. And because this is an ion, I'm going to put it in brackets and put my charge on the outside. Okay? So that's our electron structure for that. Okay? For methanol, right, what we see is that we've got 4 electrons left. Carbon is already happy. Oxygen is more electronegative, so I would want to give my oxygen its electrons. So I give it 2, 4, and it's sharing 4, so that has 8 electrons. Carbon has 8 electrons that it's sharing around it, 2, 4, 6, 8. And then each hydrogen has 2 electrons, which is all the electrons that hydrogen can get. Okay? The last one is SO3 2- here. Okay? So sulfur, right, in the middle, sulfur is less electronegative than oxygen. So I'm going to give oxygen electrons first. 1, 2, 3, 4, 5, 6. It's sharing 2 more. It's got all the electrons that it wants there. That's good. I gave it 6, so I've got 14 electrons left. Let's give 2, 4, 6, and then sharing 2 more with sulfur. That one, that oxygen is happy now. It's got 8 electrons, so we're going to subtract 6 from that. So, whoops, that gives me 8 electrons left. Let's go 1, 2, 3, 4, 5, 6 for that oxygen. Now it's happy again. It's sharing 2 electrons there, so that is at 8 total electrons around that oxygen. That gives me now 2 electrons left, and sulfur gets to be happy as well. So 2, 4, 6 electrons that are shared, 2 that are on sulfur. Okay, so now we have made all of them, given all of them a noble gas structure. Okay, we'll talk more in a second.